Greetings, Mrs. Gomez. My name is Justine Valdezco, and we're the 11th group. For the background of our chosen study, data scientist has been dubbed the sexiest job of the 21st century. A report from McKinsey Global Institute estimates that by 2018, the United States alone could experience a shortage of 190,000 data scientists with deep analytical skills and 1.5 million data-savvy managers and analysts capable of taking full advantage of big data. Whether or not such media coverage is hype, a surge in the popularity of data science will naturally create a demand from students for training in data science. Thus, it is not surprising that numerous data science programs have emerged at major universities, including the University of California at Berkeley, Stanford, New York University, and the University of Michigan. Python, however, is a general-purpose programming language, while R is generally limited to tasks within the realm of statistical computing. With Python, students learn and build confidence using general programming concepts that are common amongst other popular programming languages such as Java, C, or C++. The course also differs from typical introductory computer science courses that emphasize program design, as we integrate general programming concepts with an emphasis on data preparation, processing, and presentation. Moreover, data-intensive computer science courses, such as a machine learning course, often have one or more programming classes as a prerequisite, which becomes a barrier to enrollment for students in some fields, such as the social sciences or course. Our course has no prerequisite, and students are not expected to have any programming experience. So this is the list of the students from diverse disciplines. So this includes statistics, physics, computer science, economics, electrical engineering, and other disciplines.
Now, we are going to cover the question that the study sought to answer, the statement of the problem. As mentioned, due to the rampant progress in the development of technology in the 21st century, there is a massive influx of demand for capable data scientists. According to LinkedIn's 2017 US Emerging Jobs Report, the number of data scientists has grown over 650% since 2012. Yet, there are still too few people exploiting the opportunities in this field. That just goes to show how companies and other business entities value big data when it comes to making quicker and better marketing decisions, which will ensure their growth and longevity. The goal of the study is to educate students on the importance of data science and also to train future data scientists through their online courses. The topic of lack of data scientists in the world is also covered in other articles since it became such a big trend. The people are encouraged to pursue becoming data scientists by informing them the perks of the profession as well as the real life applications and their importance to the society in a large scale. According to Cameron Warren in his article on Towards Data Science, he said, "Don't do data science, solve business problems." It may sound counterintuitive since data science sounds like it's all about algorithms, hacking, or calculating. He makes it a point that data science is much more than that, and it could be and should be used to solve real practical problems. Rather than learning more on new algorithms and Python packages, we should focus on learning the variables that affect a business growth or fall. By identifying data sources contributing to those variables, we will find high value opportunities. He adds that a data scientist's most important skill above any technical expertise is the ability to clearly evaluate and define a problem. By working around said problem, we could decipher the needs of a business into a process where data science could be applied effectively. Lastly, data scientists should be a part of a business, not a tool to develop it. They should be prepared to proactively get involved with the business unit as a partner, not as a support function.
And we are going to discuss the data sources they used. The course was designed to cover a wide range of topics from the nature of data, to storage, to visualization, to probability and statistical analysis, to cloud and high performance computing without diving into any one subject too deeply. This was done to ensure the students would be exposed to as many new topics as possible with sufficient exposure so that they could independently explore topics of interest as desired. Overall, the class was built by using a model installation operated by the College of Liberal Arts and Science at the University of Illinois. This provided the students with a common location for obtaining all materials. Supplementary material, including reading and code examples, and online forums to facilitate class communication. However, it also forced the students to use the Git versioning tool by spending an entire lecture on Git and by hosting Jupyter notebooks for lectures and assignments on GitHub. Since the course delivered entirely online via Moodle and GitHub, it resembles a massive online open course or MOOC in several aspects. From the student's perspective, each week began with an introduction video in which we summarized the topics that we would be covered and dynamically demonstrated example codes or applications. Each week's material was organized into 3 lessons. Each lesson was comprised of a required reading list and one or more optional readings. For some of the lesson, the course provided Jupyter notebooks, which are formerly Python, while in other leverage freely available online sources. At the end of each lesson, there was a short lesson assessment with 10 multiple choices questions, and at the end of the week, there was a comprehensive quiz with 40 multiple questions. The next topic that we will be covering is the analytical tools and models they built to arrive at the conclusion. There was a programming assignment for weeks through 14 week, where Jupyter Notebook templates were provided to assist students in preparing their solutions. All programming assignments were graded via peer assessment and were possible via automated machine grading. Given the online nature of the course, there was no midterm or final exam. The Python programming language. Since the course had no prerequisite, it will be devoted into 2 weeks to the general concept of programming. For this, the students were asked to read from Think Python. This introduced conditionals, functions, the basic Python data types, the Python object-oriented approach to data, and Python data structures such as tuple, list, and dictionary. Many reading assignments were provided to the students as Jupyter notebooks, and students completed all Python programming assignments by using Jupyter notebooks. The Jupyter notebook can present and execute code, include descriptive text, and inline visualization in a single document. This technology is becoming popular as an instructional tool, and although its interface sometimes can complicate debugging, it has been found it to be an excellent tool for teaching data science. Data visualization. The next phase of the course introduced one of the most important yet least discussed aspects of data science, namely data visualization. Although only 1 week was explicit devoted to visualization, we introduced additional visualization ideas and examples throughout the rest of the course, wherever appropriate. To demonstrate the importance of plotting data before analyzing it, it showed Anscombe's quartet. It also presented ideas championed by Edward Tufte, such as minimizing chart junk, that is, just because a software package can add unnecessary embellishments to plot does not mean to users should do so. It also linked to a video of McCandless 2010 TED Talk. The Beauty of Data Visualization, which demonstrates how hidden patterns can emerge from beautiful, simple visualizations of complex data sets. Visualizing with data with Python required the introduction of the NumPy and Matplotlib libraries, which we use to demonstrate how to plot theoretical curve, how to make a scatter plot from a dataset, and how to make an histogram. It demonstrated how to use the Seaborn library to improve the appearance of a plot, and throughout the rest of the course, it is used to create a variety of plots such as box plots, violin plots, kernel density estimation plots, pair plots, distribution plots, time series plots, and heat maps. Statistical and time series analysis. It introduced the Pandas library, which introduces concepts from the R language into Python to greatly simplify work with large structured data sets. The primary objects in Pandas is the data frame, a two-dimensional tabular data structure with both row and column labels. The data frame provides sophisticated functionality to make it easy to select, group, and filter data. After an introduction of Pandas, it transitioned to statistical analysis, which is very important with large data sets, especially when it needs to make a quick decision based on summary information without being able to completely scan a potentially large data file. It is also necessary to use statistical analysis, future predictions, or better understand some physical process. All of these cases require understanding of summary analysis, density functions, distribution functions, basic Bayesian analysis, and basic statistical analysis including linear modeling and regression. For most of this section of the course, it leveraged the freely available books, ThinkStats and ThinkBase by Alan Downey. While a considerable code base accompanies this book, it encouraged students to not use the author's code, but to instead use standard Python, NumPy, or Pandas data structures. This was because Downey's code is written like a software project and is spread across multiple files and classes. While his approach makes the code quite robust and easy to extend, it felt complicated learning statistical concepts, especially for students who have little previous programming experience. Finally, it devoted 1 week to learn how to work with time series in data in Pandas and how to visualize them by using Seaborn. Time series data are everywhere. While often simple in content, example, a one-dimensional array indexed by time, they often provide rich data mining opportunities. As an example, the last lesson in this week's focus on mining Twitter streams by using Twitter's API. It also introduced Markov Chain Monte Carlo or MCMC method by leveraging Chapter 1 of Bayesian method for hackers, which demonstrates the use of PYMC to sample from the posterior to estimate model parameters. Throughout the discussion, developing and teaching this course was a both challenge and a rewarding experience. The primary challenge resulted from the need to find the right balance for students with diverse programming abilities and backgrounds. Some students had programming experience, some were already established Python programmers, while others came in with no prior exposure to programming. We tried to make the programming assignments not too burdensome for novice programmers, but it was difficult to keep more advanced students motivated, also to struggle to maintain a consistent level of difficulty, workload, assembling course material from a variety of sources.